Hello, everybody. Good afternoon. Can you all hear me okay? Okay, good. So I'm Dolly Wu. I'm the general manager from Inspur. Let me see how this goes. Let me figure out how to use this. So,
That's a transmitter.
oh, okay.
You need these.
So, okay. All right.
Because you have no place to put your iPad.
Okay. Oh, okay. So I have to. Okay. So just to tell you a little bit about Inspur, we're actually the top 5 largest server manufacturer in the world, and top 1 in China. So we're also the top 1 software vendor in China. We ship the most number of VMware software licenses and Red Hat licenses. And we are the number 1 cloud solutions provider in China. We are also an HPC expert. So we built the world's fastest supercomputer in the world, the Milky Way 2, and it's been on the top 1 out of top 500 list since 2013. So Inspur is a large multinational with 20,000 employees worldwide. And we've expanded to 85 countries and set up R&D centers and manufacturing plants worldwide. We've just established a brand new manufacturing plant in the US, in Fremont, Silicon Valley. So out of the Fremont plant, we can actually supply 10,000 servers to the US customer base. And worldwide, we can supply, we can build up to 1 million servers annually. So today, I want to introduce you to the most popular open rack scale architecture available today for hyperscale data centers. So everybody knows Facebook, OCP. That's what we're here for today, so I'm not going to spend too much time talking about Facebook. So the second open rack scale hardware platform that is very popular today and deployed today is based on the Scalable project spec from China. And then the third rack scale architecture that's being introduced is the Intel rack scale architecture. And the Intel rack scale architecture just debuted in 2014, and mass production is supposed to happen from various manufacturers, probably starting in Q3 of this year. So today's discussion, I want to focus on it's not going. Yeah, next. I want to focus on Scalable design spec and the Inspur's smart rack, which is designed based on Scalable. So just to give you a little bit of history background about what Scalable project is all about. So when the BAT companies, Baidu, Alibaba, and Tencent, started to see so much growth in the internet business that the traditional data center server and data center architecture is not being able to keep up with their business growth. So they have to find an architecture and a way to refine the growth and the efficiency in deployment. So they came together and they started the Scalable project design spec. And then Inspur was the original manufacturer that was interested and had the resources and plan to work with the BAT companies to design the next generation hyperscale data center infrastructure. So the BAT companies are Baidu, Alibaba, and Tencent. So you probably all have heard of all 3 companies. Tencent is the company that does the very popular WeChat application that everybody uses in China. And then Baidu and Alibaba, I think you all know. So in order to come up with a hyperscale platform that would allow them to deploy very quickly in massive scale and also achieve the efficiencies that they need to operate a hyperscale data center. Because in China, the electricity is extremely expensive. It's 10 times more than the US, so they have to figure out a way to reduce overall power consumption and reduce total cost of ownership so they can operate at scale. So the Inspur Smart Rack, designed based on the Scopio project specs, it's currently the largest hyperscale platform for hyperscale data centers. Next. Okay. So what is so good about the Scopio project spec? So everything, go back. Oh, sorry. Can you go back? Go back one more, good. Okay, so now the rack is now an intelligent rack. This power, cooling, and management is built right into the rack. So the server nodes themselves no longer have any power supplies, no longer have fans. So the cooling and the power is optimized at the rack scale, so the server nodes can be modular. So you can easily plug and play and maintain the data center very quickly and be able to deploy very quickly. Next. So with this type of hyperscale architecture, the internet operators realize much higher density, and the power consumption overall is reduced by 15% and up, and you can deploy a lot quicker, 15 times faster than using conventional rack and conventional data center equipment. And also the total cost of ownership reduces by 12%. And overall, failure rate reduces by half because a lot of the failable components are removed from the servers themselves. Next. So let's take a look at the Smart Rack Scopio spec layout. So everything is front serviceable. So the server nodes, all the I/O, everything is in the front. So it makes it very easy for the data center manager to roll down the I/O and just service the nodes from the front. And very easily done in a modular way. And then also the cooling zone is at the back, the fan zone is at the back of the rack. And these are all very high efficiency fans. And you can configure each fan zone according to what's happening in the front. So for example, if you have a very highly active Hadoop nodes in the front, then you can speed up the RPM speed of the fans to cool the Hadoop nodes in the front. And then if you have very passive cold storage nodes in the bottom of the rack, then you can spin down the RPM speed of the fans in the back of the cooling zone in the back. Then that way you can optimize the overall cooling of the rack and be able to realize the savings that you need in energy and cooling. And in the middle of the rack is the power bank. So the power bank supplies the power to all of the servers in the rack. And so you no longer need redundant power supplies in every node. You can just use one power bank, which has 5+1 configuration, or there are various configurations that we can set up depending on what the customer is looking for. In the US, the most popular power configuration is 208 volt, 3-phase. And then some customers want single phase 480 volt. We can customize. We have a power team that can customize the power footprint for what you need in your data center. And then another nice thing about the Smart Rack is the central management. So the central management allows you to be able to deploy very easily and configure and monitor all the fans, the nodes, and the power supplies in the full rack. So it makes it very simple for the hyperscale data center manager to deploy and to maintain and service such a rack. Next. And there are many different configuration nodes for this architecture. So if you're looking for a Hadoop configuration, the first one on the row, 1U, 1 node with 12 hot swap, 3.5-inch drives, can be the perfect candidate for a Hadoop cluster. And then the second one in the row is the 1U, 2 nodes for very good HPC application. So you can have very high density in a single rack. up to 74 nodes with 6 switches. So there's a lot of flexibility built into the smart rack itself, which allows you to have up to 6 switches in a rack, and allows you to either have a mixed rack or a homogeneous rack with various configurations and nodes to choose from. And then we also have a very popular one in the third column for cold storage with 18 3.5-inch hot swappable drive bays, which you could use for cold storage with each drive could be up to 10 terabyte times 18. So that's a lot of cold storage volume in a one-use space. So what's so nice about the Scalable project design is that it has the standard 1U height, which is 1.75 inches, and then also the depth is, the width is 21 inches, which allows us to pack more into the same space. But the outer width of the rack is still 24, the standard conventional 24 inches. Next page. Okay. Next. Okay, so for the for hyperscalers, a lot of them don't need all the extra hot swap features that enterprise customers may need. So we also offer nodes with no hot swap components. So you can have fixed drives, and then if a node is down or if a drive fails, you just pull out the entire node and then swap in another one. So that's what most hyperscalers want. They want to cut down every single penny that they can eliminate from the total cost of ownership, so they can operate at the most efficient and cost-effective way. Next. So this is some of the rack configuration samples that you can have. So we can have a, go back. So we can have a compute-intensive rack, or we can have a balanced workload rack, or a storage-intensive rack where you can have all those cold storage nodes and build up a rack with 40 nodes with multiple switches, 2U for data switches, 40U for storage nodes. Or you can have a mixed rack with different types of application nodes in it, with cold storage nodes, application nodes, web server nodes, or HPC cluster, all in one rack. So depending on the customer's requirement, we can also customize the rack, the power footprint for the overall rack. So instead of having just a single power bank, which gives you about 12.5 kW of power in a rack, we can scale up to 50 kW per rack by adding 3 more power banks, for total 4 power banks in the rack for those very high power consumption applications like GPU applications. Next. So a lot of the customers that we work with want to figure out what's the most efficient way to deploy cloud. And then there's public cloud, and then there's enterprise private cloud. So what are people looking for when the data center managers are trying to build up their cloud infrastructure in a public cloud? They're looking for MTTR, mean time to replace. They have to have very high mean time to replace ratio. And then in an enterprise private cloud, they worry more about MTBF, mean time between failures. And they want reliability and uptime to be more than 99.9999%. So we, Inspur, try to come up with different rack scale platforms for these types of demands. Next. So the smart rack is really suitable for public cloud build out and for scaling out. So we came up with a new platform based on the Intel rack scale architecture. Next. Which we call the InCloud. And then an InCloud rack is for enterprise cloud build out, which can scale up as well as scale out. So in the Intel rack scale architecture, In addition to having rack level management, rack level cooling, and rack level power, we also add in rack level switching and networking. Can we go back? Let's see. Can we go back a couple pages? Yeah. Okay. So in an in-cloud rack, in addition to being able to deploy single socket and dual socket servers, you can also do 4-socket and 8-socket servers. So 8-way servers, very powerful for in-memory applications, for SAP HANA type applications. So if you're looking for scaling up and scaling out, also you want to be able to use software-defined architecture to define the hardware pool, resource pool. The Intel rack scale architecture is a perfect platform for that. So we are the only one that currently we know of who can put 8 sockets, 8-way server into a rack scale platform at this moment. And the Inspur in-cloud rack will have samples available for POC if anyone is interested at around July timeframe. And the mass production is planned for September. Okay, next. So same thing with the in-cloud rack. You can have a compute-intensive rack, a homogeneous rack, a balanced workload rack, or a mixed rack. And then also a mission-critical rack where you can put in all these 4-way or 8-way servers for different in-memory type applications. And then next. So the future of the software-defined data center, Inspur engineers are working on pooling all the compute resources, pooling the memory resources, and pooling the drive resources into single racks. For example, in the future, we're working on having full rack of CPUs, full rack of drives, and full racks of memory. And then depending on what you need for your application, you can, through software, define what your server footprint is going to look like. For example, I want a server with 100 CPUs, 1,000 drives, and I'm exaggerating a little bit, so this is the type of work that our engineers are focusing now for the future software-defined data center. So to give you a little bit of case study about how we use the hyperscale racks and how we deploy it. So everybody probably already know Alibaba. So they are one of the top e-commerce platforms in the world. And in a single day, November 11 in 2015, the single day in China is the same as Cyber Monday here in the US. One day of e-commerce transaction at Alibaba's portal, it's $15 billion, almost 14.5 billion dollars. And that's a huge amount of transaction in a single day. And in order to get this kind of transaction volume at that speed, at that scale, and at the reliability that they need to keep the platform going without fail, they rely on the Inspur Smart Rack to power the infrastructure. Next. So another case study is Baidu. So Baidu is another one of the largest customers for Inspur. And we supply over 85% of the rack scale servers into Baidu's data centers. And we work very closely with Baidu in deployment. In the past, when we deploy conventional rack mount servers into Baidu's data centers, we were only able to deploy 300 to 500 server nodes a day. But after we switched them over to the Smart Rack architecture, we are able to deploy more than 5,000 nodes in a single day. So that's a record that we set for hyperscale deployments using the Smart Rack. So if you guys are interested in how the Smart Rack works and how it looks, and put your hands on the nodes themselves, we have a demo rack at our booth. You can feel free to come by take a look, and then we can explain a little bit more to you about how it can benefit you and how it can help you deploy in scale. And we have many customer use cases, and we want to be able to integrate the smart rack architecture into the OCP community. So our engineers are already working on technology to implement that integration. And then we will be building the OCP mezzanine cards into the smart rack nodes. So the OCP mezzanine slot has become very, very popular, even for standard rack mount servers. So we want to be able to integrate all these open hardware platforms into the smart rack and be able to contribute into the community and bring these hyperscale group into a better and more well-known status with all the data center managers, so we can leverage the technology and build our data centers quicker and more efficiently and at scale. So we see that everything is moving towards the cloud, and the digital revolution is going to move everything towards scale. So more and more enterprises are going to move into the cloud, and then we need to figure out a way to make the cloud more efficient and deploy the cloud quicker and faster. So that's all I have today, and if you have any questions, please feel free. Let me know what they are. Yes. Any questions? No questions? Okay, if you don't have any questions, please feel free to go to our booth to take a look at the smart rack. And Inspur also is hosting a open bar party at the Tang Bar, which is downstairs right at the Marriott Hotel around the corner. So you can walk down and have some drinks and socialize with our technologists and then talk to some friends and colleagues. Thank you.